Hi, everyone. I just want to say thank you for coming to our first lesson online for our math class. I'm really excited to be trying this format with all of you. I think you're going to really love it. You're going to be able to learn these lessons from the comfort of wherever you are. In math class, we're going to have more time to do more interesting and individualized activities. I'll be able to have more one-on-one time with you, which I am really looking forward to. And I don't know, I'll show you a little bit of how I live over here. Right now we are in my dining area. These are my paintings on behind me. So anyways, I hope you enjoy. Now this is our first time doing this, so as you can imagine, it's probably we're going to have a few glitches. You're more than welcome to give me feedback, and I'll do my best to make sure that all of the upcoming videos improve with time. But bear with me, and I really appreciate it. Okay, so I got to do some adjusting that needs to happen. Oh, actually, maybe I'm going to tell you this first. So today's lesson is lesson 6.3, and it's on percents and decimals and percents. Ooh. And they are highly related, as you can see. So 98% is equal to 98 hundredths. I cannot mirror point. But this is what we're going to be discussing, and we're going to be doing some problems as to why these can be converted so easily, and we're going to also look at some practical ways of applying these concepts. So come over here with me. Oh boy. All right, so I've got our notes here. Now, lesson 6.3 is on percents and decimals. So basically, when you have, let's say we have 37%. Now, I could take 37% and easily convert that. I could put, well, as you know, we could make 37% into 37 over 100. And then 37 over 100 converts to 37 hundredths as a decimal. Same goes with 76%. So I can change 76 to 76 over 100 because the percent sign means out of 100. So 76 out of 100, and that would be 0.76 or 76 hundredths. Similarly, let's say I wanted to change 38 hundredths. I can make that 38 over 100, and then that would be 38%. Okay, so by that logic, you can, it's very easy to see the rule. So to convert decimals to percents, you can just move the decimal 2 times to the right. So why don't we do a couple of those examples? So if I'm given 13 hundredths, I can simply move that decimal. Let me do this. Oh, got some shadow action here. Sorry. I can move that decimal from here, 1, 2. Decimal gets moved to 13%. And then I have my answer. In the next problem, I have 4 hundredths. Once again, I could just move it over 1, 2 times, and I get 4%. In my next problem, I have 27 thousandths. Now that looks a little intimidating because it doesn't have 2 places after the decimal, but guess what? It's the same rule. I get to just move it over 1, 2 times, and I get 2.7%. And that would be called a decimal percent. And you often see these sorts of decimal percents when people are talking about interest rates or stocks. In stocks, you have a lot of fraction percents and decimal percents. So now this is really awesome. This 2 to the right is very simple because when you want to change a percent to a decimal, let's go to that rule. Sorry about this. I'm going to have to figure out a new way to do the webcam. Okay, to convert percents to decimals, move the decimal 2 times to the left. So here I have 48%. So as I said, 2 times to the left. So we assume this is a whole number. The decimal's hiding right here. And we're going to just move over 1, 2 to the left. My answer is 0.48 or 48 hundredths. And my next problem, 9%. Again, whole number, decimal is going to be here. And so what I'm going to do is I'm going to just go over 1, 2. Now I could put a 0 there and leave my decimal there. So my answer will be 9 hundredths. And with 70, I'm going to rewrite this problem right here. Sorry. 75.5%. I could, again, I have a percent. I want to go 1, 2 to the left. My answer is actually 755 thousandths because I just had the decimal was here, 1, 2, and I have my answer, which is there. Okay, so that is how you can convert decimals to percents and percents to decimals. Let's go to example 3, approximating percents. So in example 3, we have a word problem. It says Joe saves 5/6 of his allowance. What percent of his allowance does he save? So to approximate this percent, we could do a lot of things. I mean, we could make a percent proportion. We could try to figure out using equivalent equations with 100 as a denominator. But today what we're going to do is we're just going to go ahead and do a division problem to solve this. So you are all very, very familiar with making fractions into decimals and decimals to percents. But let's go ahead and solve this. Excuse me. Excuse me. Okay, so I'm going to go ahead and put my numerator inside, my denominator on the outside, and then I'm going to add some decimals and maybe 3 zeros. Because when I want a percent, I know it needs to be tenths. I need to get to the hundredths, maybe even the thousandths. So 6 goes into 50. Oh boy. 4 times, no. It goes in there 8 times. 8 times 6 is 48. And I get 2. I bring down that 0, 6 into 20, 3. That's 18, 2, 0, getting some tea made in the background, 3, 18, 2. And as you can see, this is just going to go on and on and on. So that is why I think this is an approximating percents problem because, you know, we have to just sort of round this one off. So in this case, it seems as though Joe saves. Now I'm going to go ahead and change this to a percent by moving 2 times to the right. 1, 2, and I get 83.3%. So Joe saves 83.3% of his allowance. All right, let's move to example 4. This is a very long problem, but it's about geography and it's about lakes. So, and through this problem, we're going to talk a little bit about small and large percents. Now, I have a paper here that I drew for you guys. It's not a good... I'm sorry about this. Let me find this paper. It's a little bit... Huh. Here it is. Okay. So, a small percent would be described, as you can see here, it's 0.5%. So that's a very small percent. That's 0.5%. So in this square with 100 squares, you could see that 0.5% would be represented by just filling in half the square. But a really large percent, you would almost need, you would have to color it in. I don't know if you could tell that it's highlighted, but we've got this whole thing. This whole thing is colored in. That's 100%. And then we have up until this point here, which is 150%. So these would be considered, this would be considered a large percent because it's over 100, and this is considered a small percent because it's less than 1%. So that being said, we are going to work some problems with large and small percents. So back to the lakes. We have Lake Englebright, Lake Tahoe, and Clear Lake. So the surface of Lake Englebright is 0.7% of the surface area of Lake Tahoe. The surface area of Lake Tahoe is 282% of Clear Lake. Write these percents as decimals. So, okay, we have 0.7%, so they want us to change this to a decimal. Okay, so we go 0.7, we move over 1, 2, oops, nope, wrong way, sorry. 0.7%, we move it over 2 times to the left. So this is represented by 7 thousandths. 7 thousandths. And then the surface area of Lake Tahoe is 282%. If I change that to a decimal, that's going to be 2.82. So Lake Tahoe is 2.82 or 2.82 times larger than Clear Lake. So Lake Tahoe is the largest lake of all of those. All right, let's keep going. Let's do a geography problem. Oh no, actually let's write some small and large percents. So in this case, we want to write 3.5 as a percent. So 3.5, I can change that to 3.5. Okay, and if I change 3.5 to 3.5, I can simply move that decimal over 2 times to the right. So 1, 2, 350%. So 3.5 is 3.5. 3.5 is 350%. Now, if I want to write 7 3/4 as a percent, I can make 7.75, and then I can move my decimal 2 times to the right, 775%. Okay, now what if I want to make 8 10,000ths into a percent? Well, same rule. I just move with that decimal over 1 2 times, and I get 8/100ths of a percent. 8